Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're going to be talking about Emirps. And you're thinking, what in the world is an Emirp? An Emirp is nothing more than the word prime spelled backwards. See, an Emirp is a special number. It's a number that not only is it prime, but when you flip that number is also prime. So for example, if I took the number 13, well, 13 clearly is prime. If I flip that, that means that I would get 31. The question is 31 prime? Sure enough, 31 is prime. Therefore, 13 and 31 are Emirps. Okay, so then let's go from here. How about 14? No, 14 can't be prime because that's an even number. 15? Nope, that's divisible by 3 and 5. 16, that's divisible by 2. 17, so I know that 17 is prime. How about its flip, which is 71? Well, 71 is also prime, so therefore 17 and 71, those are considered Emirps. The next number is 18. Nope, that's divisible by 2. How about 19? Now, 19 is a weird one here because 19 is in fact prime, but its flip is 91, and 91 is really the same thing as 21 times 7, so that's not prime. So 19 is not listed here, nor is the number 91, because even though 19 is prime, its flip, or its reverse, which is 91, that is not prime. So therefore 19 would not be considered an Emirp. It'd be considered a prime number, but not an Emirp. And an Emirp is only when that number and its inverse are both prime. Okay, so that's what we want to do. We want to ask the user, how many Emirps do you want to display? Now, you'll notice also that we cannot display palindromic primes. A palindrome is basically that the reverse is the same thing as the original. For example, the word Bob is considered a palindrome because B-O-B reversed is B-O-B. Radar, R-A-D-A-R is the same thing reversed as R-A-D-A-R. So radar, Bob, kayak, those are considered palindromes. We don't want to display palindromic primes. For example, 2 inverse is 2, 3 inverse is 3. How about 11? 11 inverse is 11. 101 inverse is 101. 131 inverse is 131. These are primes, yes, but they're palindromes or palindromic primes, and we don't want to display those. So that's part of our consideration over here. We want to make sure that the number is not a palindrome. Okay? We're going to create 2 functions to help us out. You're going to create an isPrime function, and basically that's just simply going to return true or false. Is the number that I gave to you prime? Yes or no? We're also going to create this function over here. Is it an Emirp? So if a number is a prime, that's step 1. The question is, how about its flip? Is that also prime? So if the number that I give to you is 17, you're going to flip it and turn it into 71. You're going to ask, is 71 prime? And you're also going to ask, is 71 a palindrome? If it's a prime number and if it's not a palindrome, then we return true. Right? So I give you the number, you're going to return true. This thing really is an Emirp. Or maybe it's not. Like, for example, 19. 19 is prime, but it's not. But 91 is not, so therefore it's not an Emirp. Okay? All right, so that's what we're going to build. So let me switch over here to Visual Studio. And actually, let me go ahead and close this solution. And I'm going to start a new project. It's going to be a Win32 console application. Double click over here. CS225. Now, we're really going to be working with strings. And a string is, you could think of that as a single dimensional array because we're going to be able to move these numbers around. What I'm going to do is I'm going to take that number, like 101. And the first digit is index 0. The second digit is at index 1. The next digit is at index 2. And I want to reverse those. And I want to see whether or not that we have a palindrome. Okay. All right, so I'm going to put this under the category of strings. And we're going to call this the Emirps project. And I'm going to create an empty project. And of course, I'm going to go to Solution Explorer, Source Files, add a new item. C++ item is fine. Let me go ahead and type in my boilerplate code here, which is include IOStream. And I'm definitely going to be using the string library because, see, here's what I'm going to do. Let me just type in some comments, then I'll get rid of them. I'm going to ask, okay, well, first of all, is 19 rather a prime number, and also is its inverse a prime? Well, that 19 is really going to be treated as a string at index 0, and then I have index 1. So the 1 is going to be stored in index 0. The 9 is going to be stored in index 1. So I'm treating this as a string. Then what I'll do is I'll reverse it. And so the reverse will look like this. Let me put in a 9 over here for index 0 and a 1 over here for index 1. And so then I'll turn this into a number and ask mathematically, is this thing a prime number? Okay. So that's when I need a string to be able to flip these digits around. Now there are other ways to do it. I'm just showing you this way just so that I can say that this was a strings project. All right, using namespace std int main, and whoops, sorry, didn't mean to cut off that parens. Get rid of that parens over here. And what we're going to do is we're going to say declarations. We're going to get the user input. We're going to perform a calculation or calculations. And then we're going to generate the output. And of course, we're going to have system pause so we can stop our program, take a look at what's going on, and then return 0. All right, now before I do this, before I do this, let me go ahead and create the functions that I'm going to use. And according to the handout that I gave to you, you're going to create an isPrime function. It's going to return a Boolean. The name of the function is isPrime, which in other words is really asking a question. Is this thing a prime? That's what this function is going to determine. So I've got to give you a number. So let me give you a number. I'm going to call it possible prime parameter. So I'm going to give you a number, an integer. You determine if whether or not this thing is prime. I'm also going to have you create another function called isEmirp. I will give you that same parameter, and you will determine if whether or not the number is an emirp. First test, is it a prime? So 17, is it a prime? Yes. Then I will send the 17 over here. This guy is going to flip the 17 to 71. It's going to determine if it's prime. It's going to determine if it's a palindrome. And if it's not, then it's going to return true. It's a prime. So therefore, 17 is a prime. I'm sorry, 17 is an emirp, and also 71 is an emirp. That's the kind of processing that we'll go through. So let me take these two guys. I'll include the semicolon as well because I'm going to get rid of those. And at the bottom, I'll paste. I'll get rid of that and put the open and close curly braces. Same thing over here. I'm going to put an, oops, I put a square bracket. What I meant to do was to put the curly braces like that. All right, so let's work with isPrime. Now, the way that you're going to determine if a number is prime is to simply divide it by 2, 3, 4, 5. You're going to divide it by all these numbers, and we're going to see if it's divisible by any of those numbers. Now, if the number is 30, you wouldn't divide it by 2, 3, 4, 5, 15, 16, 17, 18, 28, 29. You wouldn't divide 30 by 28, 29. Clearly, it's not divisible by 28 or 29, the number 30, that is. So you would only go up to half that number. So 30 is the number into consideration, then only see if it's divisible by 2 all the way up to 15. If we're considering 100, you would go from 2 all the way to 50. Okay, so whatever the number is, divide it by 2, and that's how high you will go in terms of division experiments. So we're going to call that a divisor. Okay, so first of all, I'm going to create a counter. I'm also going to create the halfway point. And I'll ask within an if statement if the possible prime number is less than 2. Because if you gave to me a number that's less than 2, then I'm just simply going to return false. It can't be a prime number. It's less than 2. 2 is the first prime number. All right. How about this? Another consideration. I'll say else if the possible prime number is 2, if it's equivalent to 2, or if the possible prime number is equivalent to 3, then yeah, I'm going to return true. Right? Because 2 and 3, those are definitely prime numbers. What if the number is not less than 2? What if it is not actually 2 and actually 3? Then that would mean 4 and above. So I'll have an else statement. And in that else statement, I need to determine, first of all, what's the halfway point? So half will be, I'm going to cast this result as an integer. What I'm going to do is I'm going to take the possible prime number, and I'm going to divide it by 2, which is an integer. So this may be 17, and so 17 divided by 2, that's going to be 8 point something. Right? Well, I don't want the point something. I just want the 8. And that's what this does. This will cast it so that if it's something point something, it gets rid of the fractional part and only keeps the integer part. For example, 5 divided by 2, well, you know that's 2.5, but we just want the 2. We don't want the 0.5. Okay? So that's what the halfway point represents. Then I'm going to start our counter from 2. Counter is really a divisor. Counter at first is 2, then it's 3, then it's 4, then it's 5, all the way up to and including the halfway point. All right, so now that I have this established, let's go ahead within a while statement. As long as that counter is less than our halfway point, so as long as it's less than or equal to our halfway point, here's what we're going to do. I'm going to say if the possible parameter that you gave to me, I don't know if it's a prime number, but I'm going to use the modulus to see if it is divisible by whatever the counter is. How do I know if it's divisible? The remainder is 0. Right? If there is a remainder, then clearly it's not evenly divisible. If you are divisible, then I'm going to return false. You are not a prime. Right? If the modulus of whatever that counter is with whatever the prime number that you possibly gave to me, the possible prime number, if that results in a remainder of 0, clearly you are not prime. All right? So we'll try 17, say, for example. We'll try the number 2. All right? That results in a remainder. So we're going to try it again and try it again with counter equal to 3, then 4, then 5, then 6, all the way up to half of 17 in that particular example. All right? What if this is not the case? All right? So if this is not the case, well, then I just simply take that counter plus equals 1. So I'm going to increment it by 1. All right. So remember what I said over here. I have return is false, return is true, and what I'm going to return false or return true, I should say. And then I'm going to go through this while statement. Okay, so what this thing is going to do is it's going to keep on determining if whether or not it's divisible. If it isn't, it'll return false. If this while statement doesn't find any divisibility, then I simply return true. And so that's how we find out if the number is prime. Go all the way up to half that number. If any of those numbers from, see, counters 2, from 2, 3, 4, 5, 6, 7, 8, all the way up to half, if none of those results in a remainder of 0, then we're just simply going to return true. If it is evenly divisible by something, then I'll return false, and we'll never see that return true statement because it jumps out of the function. All right, does that make sense? Comments or questions about that? So that's, I'm going to go ahead and minimize that. That's my function is prime. Now let's work with the is Emirp. So a couple of things need to be considered. First of all, we need to flip the number that you gave to me. So if you gave me 17, I need to flip it to 71. Guess what I'm going to do? I'm going to go right back over here and call and say, hey, it's 71 prime. The next determination is to see if it's a palindrome. In other words, if it's reverse, 17 and 71 clearly are not palindromes, but not palindromic primes. But 101 is 101. If I reverse it, it's 101. So those are the two considerations that I need to factor in. All right, so over here, let me go ahead and create a counter. I'm going to create a string called Emirp string. I'll set it to nothing at first. I'm going to create another string that I'm going to have as a temporary string. I'll also set that to nothing. All right. Now, the first thing that I need to do is to put into Emirp string, I'm going to use the to_string function. So all this does is it just converts to a string, whatever the number is that you gave to me. So I'm going to give to you possible prime parameter. See, that's the number that I gave to you. That's a number. See the word integer right below it? I need to convert it into a string so I can put it over here. All right. Then let me go ahead and get that length. So I'll say counter and emirp string dot length, because my intention is to reverse that number to find out if its reverse number is in fact also a prime. So what am I going to do? I'm going to make temp the reverse of emirp string. For example, 13 becomes 31, right? The reverse of it. Now, there are functions that you can use to reverse strings. I'm just doing it, old school way. I'm taking, for example, let me just write a comment over here. Let's say, for example, that I had index 0, index 1, index 2, index 3. And let's say that I have a number over here, like 1 and 3. I guess I didn't need to create all those others here. So what I'll do is, well, no, I do need to do that, just so I can explain the concept here. Let's say, for example, that I have this. Okay, I don't need that index. All right. Well, what am I going to do? I'm going to take this number and put it into index 1. I'm going to take this number and put it in, I'm going to leave that alone rather. And I'm going to take that number and I'm going to put it over here. So I'm going to flip these numbers, right? So let's see here. If I had 4, or like that, and let's say that I had this. Okay, so that means that this number would go over here, 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 right? So again, we're just flipping them around. How do you do that? So we'll use within a while statement. Let me let the counter, as long as the counter is greater than 0. So obviously we're going to be doing some form of decrementing. Okay, so temp is going to be temp. We're going to concatenate that with, okay, emirp string. This is nothing more than an array of characters. So I'll take a look at that counter, -1, and then I'll take that counter and I'll decrement it by 1. Okay, so let's see what this looks like here. Let's experiment with this. I'm going to have a comment over here. And let's say that for this index 0 and index 1. Okay, and then the number that I'm considering is 17. So I need to get its flipped version, which is 71. All right. So temp, let's see here. Over here, temp is nothing. It's been set to blank. I take emirp string. So emirp string, that's what this is. So I'll do this. I'll say this is, sorry. This is emirp string, right? All right, so that's my possible prime, but it's in the form of a string, so there are quotation marks around it. All right, and then I know what the counter is. The counter is the length of that, so in this case it's 2, so I'll just do this. I'll put counter is 2, because I have 2 items here. All right, so I've got that length. Is 2 greater than 0? Yes. All right, take temp, which as you can see is blank. Concatenate that with, okay, so let's get this emirp string. Counter, as you can see here, counter is the length, right? So it's 2. 2 minus 1 is what? That's 1. Well, what is in emirp 1? Well, in emirp 1 is 7. Do you agree? That's in that position right there. So what that means is that so far in temp is going to be the string 7. Right. This is nothing. Concatenate that with 7. So the new version of temp is this right now. Okay. Count -1. Okay, so now counter is going to go to 1. Is 1 greater than 0? Yes, it is. Okay. Take temp, which you can see this is what temp is. we're going to concatenate it. So in other words, we're going to add something here. Do you agree? Okay, so what are we going to add? Well, so counter is 1. 1 minus 1 is 0. So emirp string 0. Well, that's the number 1 right here. So I put the number 1 right here. So do you see how I'm basically using this to flip it? I'm using a string to just take the 1 in the sense. So if I had 1791, well, this little while statement just simply flips everything around. Okay. So that's how the while statement works. Now that I have flipped the number around, let's do this. Let's determine, if possible, emirp parameter is a palindromic prime. That is, so for example, I should say, 101 reverses to 101. We don't want that. Okay, so how do I do that? Well, first of all, temp, as you can see, is a string. Now that it's been flipped, now that the 17, say for example, has become 71, I need to convert that string back to an integer so I can do math. So what I'll do is this. If I'm going to use STOI, that's an abbreviation for string to integer. What am I going to be converting? I'm going to be converting the temp string into an integer. So in other words, let me just write this comment down. 17 string becomes 17. In other words, you see how this 17 doesn't have quotation marks around it? That's what we're trying to do. We're just trying to convert it to a number. Specifically, I is an integer, string to integer. So I call this, and then I say, is this equal to a possible prime parameter? All right, so let's think about what we're doing. I gave to you the number 17. Temp is the inverse or the reverse of 17. So this is 17, this is 71. Is 71 equal to 17? That's what I'm asking. It's not, so test number 1 passed. You're not a palindrome. Okay, how about this? I gave you 101. Temp is the reverse of 101, which is 101. Is 101 equal to 101? Yes. Okay, you're a palindrome, therefore you can't be an emirp. Do you see how this test works? All right, so in the if statement, if you are equal to your reverse, then I'm going to return false. You're not an emirp. Okay, so that's the easy test. I send you 101, 101, hey, wait a minute, 101 is the same thing as 101. I gave you the number 7, hey, wait a minute, 7 is the same thing as 7, reversed. Okay, I gave you 17, okay, that works, because 17 and 71. But do I know that 71 is prime? So that's what this else statement is all about. So over here for the else statement, well, let's see if that number is prime. I gave you 17. Let's reverse it. 71. Is 71 prime? So if, let me call is prime. And let me give to you string to integer, the number temp, or the string temp. This is quote, 71 close quote. Now it becomes 71, and I'm sending 71 to is prime to figure out if this thing is a prime or not. So let me just make sure my parentheses are balanced. So over here, if this thing is equal to true, then I'm going to return true. You gave me 71. Where is it? Yeah, possible. You gave me 71. All right. Now I'm going to reverse that. I'm sorry. You gave me 17. Now I'm going to reverse that at 71. Is 71 a prime? If it is, then not only was the 17 that you gave me a prime, the 71 is also prime. Yes, this thing is an emirp. Otherwise, return false, which means it's not an emirp. Comments or questions on how I am using strings which are really nothing more than single-dimensional arrays of characters, right? How I'm using the string to take that number and flip it around, and then turning it back into a number to figure out whether or not it's prime. Comments or questions. Okay, so that's how STOI works. S2I, string to integer, and then we have a little while statement to reverse everything. Strings are nothing more than arrays, single-dimensional arrays. Okay, so now that I have my tools, now I can finally go back to my main program and do what I'm supposed to do. So first of all, I'm going to need to know what the user number is, because the user is going to let me know how many of these Emirps that they want to see. Okay, now I already know that the first Emirp is 13, so I'm just going to do a little cheat, and I'm going to say for my counter, I'll set it to 13, since I know that's the first Emirp. If you guys wanted to start from 2, you could go ahead and do that, but I know that by definition, 2 is palindromic, 3 is palindromic, 7 is palindromic, so I'm not even going to bother including those. So I know the 13 is the first Emirp. All right, so then I'll say nums displayed. How many numbers have I displayed? Well, I'm going to set that to 0. The user will tell me how many they want. This will be compared to the user's number. Have I displayed? This will go up to 1, 2, 3, 4, and we always are going to compare that to the user number to figure out how many numbers we've displayed. I'm going to create a string called possible Emirp. I'll set it to nothing, blank. I'm going to create another string called output. This is going to be the concatenation of all the Emirps that are sent back to me. Okay, in terms of the get the user input, let's ask the user for the number of Emirps. Let me see, what did I say to the user? How many Emirps do you want to display? How many Emirps do you want to display? We're going to see in that value, and we're going to put that into user num. Okay, so now that I know how many the user wants to see, we can go over here to the calculations section. Now, if the user wants to see only one Emirp, well, then that's easy. I can just simply say output. Oops, I'm sorry. I didn't spell this right. If the user number is 1, they only want to see one Emirp. Okay, fine. I'll send you the number 13. And then I'll just simply say cout output, and then go to the beginning of the next line, and done. But what if the user wants to see 2 or more Emirps? Well, that's what this else section is going to do. So in the else section, all right, so we know that they want to see more than one Emirp. So now I can establish the counter at 14 and then go from there, 15, 16, 17, so forth and so on. Okay. I can also say that the output right now has the number 13 in it, because that's the first Emirp. You obviously wanted to see more than one Emirp, otherwise this would have been true. So the first Emirp is 13. Now let me display the remaining Emirps. So how many numbers have I displayed? I've displayed one number, the number 13. Okay. Now let's display the rest of them. So I'm going to have a while statement. While the numbers displayed is less than the user number, then I'm just going to keep on displaying more and more numbers. As long as I have not displayed enough numbers, keep looping. Okay. Well, what's the first thing that I'm going to do? Well, I'm going to have an if statement over here. I'm going to call is prime. Let me put an open and close, sorry. Is prime. Open and close parens, put my cursor right back into there. What am I going to send to you? I'm going to send to you the counter. Counter right now is 14. I'm going to send to you the counter. If you tell me that this number is prime, well, then I have another test for you. If it comes back as prime, then I have to ask you, is it also an emirp? I'll send you counter. If it's true that not only is this thing a prime number, it's also an emirp, well, then the output is going to be concatenated with a space, and then I'm going to convert to a string whatever the value of counter is. Then I'm going to say num is displayed rather, is going to be incremented by 1. Let me slow down. Are you a prime? Check 1. How about this? Are you an emirp? Check 2. If you are, whatever the output currently has, which in this case is the number 13, let me now add this new number, which is the next emirp, to the output. And I'll also need to keep track now. I've got 2 numbers displayed, maybe 3, 4, 5, as long as I haven't displayed numbers in accordance to what the user wants. Okay. All right, so this counter really is the potential emirp. Now, after this curly braces, which is the outer if statement, then we're going to take that counter and we're going to plus equals 1. We're going to increment it by 1. Because, see, it goes from 14, then to 15, then 16, then 17, and 18, so forth and so on. And we just keep on looking at these numbers, finding the next emirp. When we're done, then we go to the output section and we just simply send out whatever the variable output is. And we'll go to the beginning of the next line and del. Let me save the program and run it and see what happens. How many emirps do you want to display? Give me 20. Wow, that was pretty fast. Now let me see if that's correct. So let's see here. I've got 13, 17, 31, 37, 71, 73, 79, 97, 107, 113, 149, 157, 167, 179, 199, all the way to 311, 377, 347, and then finally 359, 389. Yep, looks like it works. How about if I wanted to see less than that? Like, just give me the first 5 emirps. 1, 2, 3, 4, 5. Yep, and we know that 13 and 31 go together. The 17 and the 71 go together. And if I did go an additional amount, then we'd see a 37. We would see a 73 over here. Okay, and that's it. So in this particular project, a couple of beautiful things are happening. First of all, the usage of functions to determine if something is prime or is emirp. That really does a lot of our work for us. So that we can just simply ask questions. Hey, are you a prime and are you also an emirp? By the way, I could have combined this into a single if statement with an and operator. Right? Let me just do that really fast here so you can see what I'm talking about. If is prime whatever the counter is, equals true, and if is emirp, whatever that counter is, equals true, then do this, copy, paste. Let me comment this out. So I could have just done that in one single if statement, right? Using the and operator to determine if it's true. Let's see. First 5 palindromes. Yep. I just broke it up so you can understand the concept. And then, of course, these functions. Wow, I love these functions here. Now you can, by the way, in the future, if you wanted to use this to determine if a number is prime, this will work. It may not be necessarily the most efficient way, but it works. And especially with your processor, I think that it'll calculate it pretty quickly. You understand about the concept of finding half. You understand about casting numbers so that we can get an integer, using the modulus operator to see if it's divisible by something. And then the same thing over here with a possible prime parameter. This was really cool. Taking a number that I gave to you converting it to a string, taking that string, reversing its contents, and then converting that string back to an integer to see if it's equal to itself, if the flip is equal to itself. Right. So a lot of cool things took place in this project. And that is it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.